So this is CP quiz 2, starting with number 2 here. It says 3 out of the packages of 25 batteries were defected. All right, so 3 out of 25. What is the percentage of the batteries in the package that work? Okay, so that tells me if 3 of them don't work, then 22 of them do work out of 25. And if I want to know the percentage, well, then I just multiply the fraction by 100. So I believe the answer is, looks like J would have to be, oh, sorry, not J, K would have to be the answer. And that's it. So let's move on to problem 8. So for 8, it says, which of the expression is equivalent? All right, so we have an algebraic rational expression and one of these. So looking at the answer, I'm thinking I probably need to factor a little bit on the top and bottom. Like this is a 2 and a 6, and so I can pull out probably a 2 on the top because 2 and 6 both are divisible by 2. So that would leave me with an x and a 3 because 2 times x is 2x and 2 times 3 is 6. I'm going to do that also for the bottom. So the bottom has a 3, an x plus 3, so I can't factor that out, but I can factor out a 3 out of a 3 and a 9. So 3 times x minus 3. So I factored out a 3 from both of these. And so when I see this, I notice that I can cancel out the x plus 3s because there's one on top and one on bottom. And so that really leaves me with a 2 on top and a 3x minus 3 on bottom. And so the only thing that looks like that is J. All right, so that is number 8. I believe it's J. Number 14 says a group of students fill an entire row in the auditorium counting from left. Okay, so I'm going to do left and right. Matt is seated on the 4th, 1, 2, 3, 4. So here's Matt. Counting from the right, he is 15th chair in a row. Okay, so in this case, he is the 15th. He's actually the 15th person if you're coming from the right. What is the total number of chairs in a row? Oh, that's easy. Okay, so if you're starting, so if he's really the 15th person from the right side, and that means there are 3 more people to his left. So 15 plus 3 is 18. There are 18 people on this row. All right, number 20. So going down to 20 here, it is how many sections on the spinner below should be colored red. So we want to know the number of red. In order to make the probability not landing on red, 0.375 in a spin. Okay, so basically when I look at this circle, there are 8 sections. So if I don't want red, I need to multiply this by 0.375. So I'm going to multiply this. So 8 times 0.375 gives me 3. So this is what's not red, because that's what they told me this probability is not for red. So that means if 8 of them are not red, if I want to know how many are red, I just subtract it from, if 3 of them are not red, then I just subtract it from 8. So that means 5 are red. There we go. That's it. So that's number 20 is H. 26, what are the solutions of this here? Okay, so it looks like a typical algebraic problem, so I might just multiply in my x and try to get x by itself. So 3x squared minus 4x equals 4. It's a quadratic. Anytime you have a quadratic, you want to try to put it in standard form, which is this format. So you want to try to get one side to be 0. So I'm going to move over the 4 by subtracting it over. So I just move this guy over by subtracting. And then I might use, I'm going to just go ahead and use a quadratic formula. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So my a is negative 4 plus or minus the square root of b squared minus 4a. So this is my a, b, and c that I'm talking about. So my a here is 3, my c here is negative 4. So I'm just using the quadratic formula. You could also try to factor 2. I think that's possible. Let me make sure I plugged everything in right. That's a. Okay, so this would become a positive 4 plus or minus. This would be negative 4 squared is 16 minus. So those are two negatives, so that becomes a positive when you multiply. So 4 times 3 times 4. 4 times 3 times 4 gives me 48 over 2 times 3 is going to be 6. And so from here, I have 16 plus 48, which is 64. That's not a bad number, so 64. So the square root of 64 is 8. So there are two answers here. You can have x equals 4 plus 8 over 6, which would be 12 over 6, which is 2. Or you can have 4 minus 8, which would be negative 4 over 6, which is negative, if you reduce negative 2 over 3. So the answer would have to be, I believe, K is for 26. All right, 32 is about a fish tank, has a length of 24, width of 8, a height of 10. If the tank contains 1,000 cubic, so this is the volume, is what we have. What is the depth? Okay, so the depth would have to be here. Basically, the height of the water. It wants to know the height of the water. Okay, so first off, volume is always length times width times height, or you can switch height out for depth. So what we know is the volume is 1728 is equal to the length. Now the length here could be 24. And the width here would still be the width of this rectangular prism. So I know 24 times 8 times the depth, which is what I don't know. So basically I can turn this into an algebraic problem. I just need to kind of solve for this. So 24 times 8, if I combine that, is 192. I need to divide the 192 over to cancel. So 1728 divided by 192 is 9. So I believe J is the correct answer for 32. All right, moving on to the next one here. So 38 is a geometry problem where you have a right triangle and it wants to know what is cosine of B. So first off, it gives you cosine of A is 1/2. So if you know SOHCAHTOA, cosine is this CAH, which represents cosine is always adjacent over hypotenuse. So in that case, I know that cosine of A is 1/2. So adjacent would have to be, with this angle, has to be right here. So this has to be 1. And then hypotenuse is 2. So the hypotenuse is always diagonal from the right angle. So this has to be 2. So if I want to know what cosine of B is, which is this particular part here, so this angle, then I need to know what this side is because this would now be the adjacent side. So to figure that out, I need Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. Well, I know that this side's 1. I don't know what this side is. I'm going to call that b. And I know that my hypotenuse, which is c, is 2 squared. So 1 plus b squared equals 4. I would subtract the 1 over, so that becomes a 3. So b is the square root of 3. All right. So that means cosine of b is the adjacent, which is square root of 3, over the hypotenuse, which is 2. So I believe the answer is going to be H in this case. All right. 44. So this one is, which of the following must be true given the condition? So it says X is bigger than Y and Z is bigger than Y. So that tells me that Y is the smallest out of X and Z. So in this case, it says X is bigger than Z. I don't think that can be true because we don't know what's the relationship between X and Z. Okay, we just know that they're both bigger than Y, but we don't know how much bigger. So I don't think it's F, nor do I think it's G, because that's like the same thing. I don't know if Z is bigger than X because I don't know how much bigger Z is of Y. If I were to square X, it would be bigger than Y squared. I don't think that could be true because it already says that X is, well, actually, I think that would have to be true. It would, no, wait, hang on. Let me think about it. So if your X was squared, would it be bigger than your Y squared? Well, actually, that would change the game because what if Y is a negative number? What if all this time Y was negative? What if Y is negative? Because if that's the case, if Y is a bigger integer but just negative, if you square it, it turns positive, X might no longer be bigger. So I don't think this could be true either. Same thing for J as well. Like if you square Y, it could be end up being bigger. So I think it has to be K, because if you multiply 2 with Y and Y happens to be a negative number, then X plus Z, these two happen to already be bigger than Y. If you add them together, they should be a bigger number. If you multiply 2 times Y, it's not going to change it to a positive. So I think K has to be the right answer. That one's tricky, which makes sense because this is already problem 44, so it's getting harder. All right, let's get to problem 50 here. It says the length of a radius circle is 3 times, so let me draw. So here's circle A, circle B. It says the radius is 3 times longer than radius of B. So I'm going to call this 3 times bigger, and then this is just 1. So if this is a radius of B, A has 3 times larger of a radius. If the area of a circle is X, so A's area is X, what is the area of B? So this is the area for A, and this we want to know what's the area for B in relationship of circle A. Okay, so in this case, we know that to find the area of a circle is pi r squared. So this would be pi 3r squared, which would end up being pi 9r squared, because 3 squared is 9, and then r squared. So this ends up being 9 pi r squared. Okay, and then this would just be typical pi r squared. And so if we look at their magnitudes, it looks like in relationship, this one compared to this one here, A is 9 times larger. So if this is the area of this circle for A, then B has to be, let me write it here. So the area for B would have to be the area of A, which is X. Oops. There we go. They said that the circle for A has an area of X, right? So in relationship to B, the area for A is a 1/9 of A. So the area for B is a 1/9 of A because A has 9 times its amount. So I would probably choose F. That one's kind of tricky too. 56, it says in the figure below, line 1 and 2 are parallel. So this is a geometry problem, I would say. So you have to figure out which one is not true. So the following are all true except. Okay, so we're looking at the angles, it looks like, and we need to figure out if the equivalence is true, or if the equation is true. So looks like what I'm going to do is that this is like an obtuse and this is an acute. So I'm going to call that O and A. So O is obtuse and A is acute. So this would be acute, obtuse, obtuse, acute, acute, obtuse. That usually helps me when I'm looking at the angles. So this is saying A plus B. So that would be O plus A and obtuse added with a acute. And G and H are down here, which is also another acute with an obtuse. So this is true. So it can't be F because this one's true. F minus H. So if I take F, which is an acute, subtract it with an H, which is an obtuse, then take a C, which is an acute, subtract it with D, which is also an obtuse. So this is also true, so it can't be G. All right, let's try out H here. This is A, which is a obtuse, plus an H, which is obtuse. So they're both obtuses. And G is an A. Ooh, I can already see there's something wrong. And C is an A, which is an acute. So these are not equivalent because the obtuse are going to be way larger than the acute. So I think H is the one that doesn't work here, is not true. All right, I think that's all. That's all 10 problems. All right, I hope you guys found this helpful. Bye, guys.